And here we go again, back with tissues. This time we'll be focusing on specialized connective tissue. We're going to be honing in on some specialized connective tissue today, including cartilage, bone, and blood. We'll continue to look at how this connective tissue is classified and being able to visually recognize each connective tissue type. When it comes to all of our 11 body systems, they are going to be made up of only 4 tissue types. However, all of the body systems that we talk about in 201 and in 202 are going to include this connective tissue. So even when we're talking about muscular organs, they are deeply involved with connective tissue. When we talk about nervous tissue, we'll also talk about the supporting connective tissue structures around them. And then we even have specialized connective tissue, which we'll hone in today, that includes blood and bones. Specialized connective tissue. Recall all of connective tissue comes from the mesenchyme stem cell line. So these mesenchymal stem cells can differentiate and go down many different lineages. They're stem cells. They can become any of these tissue types. So these stem cells will proliferate, meaning they will become specialized, and they will commit to one of these cell lines. So when we talk about bone, those cells were mesenchyme stem cells, but when they specialized, they got a job and they committed to being a bone cell. So they go down the osteogenesis stem cell line. Cartilage is going to come from the same mesenchyme stem cell line as the osteogenesis cells. However, these guys have committed to becoming cartilage. So chondro means cartilage. Myogenesis is when these mesenchyme stem cell lines commit to becoming muscle cells. Bone marrow cells will go down the marrow-stroma cell line and commit to being stromal cells, while tendons and ligaments, those are going to come from fibroblasts. And so fibroblasts are the cells that have differentiated, and they are going to lay down all of the fibers that we find in our tendons and ligaments, all of those collagen and elastin fibers. These mesenchyme stem cells can also differentiate and become adipocytes, so they can go into the adipose stem cell line. There are others. Right? There are other connective tissues, but they all come from this mesenchyme stem cell line. So we're going to talk about how these cells differentiate into osteoblasts, chondrocytes, and fibroblasts today. Right, so remember that this connective tissue is the most abundant and widely distributed type of tissue in the body. And we're going to focus on cartilage. So with cartilage, there is no blood vessels. There's no blood supply here. We already talked about some of the traditional connective tissue, and then we'll talk about cartilage now, and then we'll talk about bone and blood. So with the cartilage, this does not only not have any blood vessels, but there's also no nerves. And there are 3 types of cartilage that we'll talk about. There's hyaline cartilage, fibrocartilage, and elastic cartilage. Yes, it's different than the elastic connective tissue. Cartilage is going to be produced by those cartilage cells. So chondro means cartilage. Cartilage is a stiff connective tissue, but it's still kind of flexible. And what gives it that characteristic is that the ground substance is no longer watery now. It's more firm. It's more like a rubber matrix instead of that gooey, soft ground substance. And that stiff connective tissue is still going to have some flexibility, which is going to give us shapes to our ears, the tip of our nose, and the larynx, which is in your throat. So what is producing the matrix and the fibers in the cartilage are chondroblasts. Chondro means cartilage, blast means immature cell. I always remember that the blasts are the younger cells that are building. Usually in construction, the young men are the ones building things. So the chondroblasts are the cells that are producing the matrix. Well, as they're producing the matrix, they're gonna get trapped because the matrix is now firm and they're not gonna be able to move around. So as they're building the matrix, they're gonna get trapped and they are going to continue to build that matrix all the way around them until there's only a little bit of space left for them to live in. Once they get trapped in that space, they will differentiate and they will turn into a chondrocyte. So this is a mature cell that is trapped in that space called the lacuna. And these cells will maintain the tissue. There is going to also be a sheath of dense, irregular connective tissue that will surround the elastic tissue called the perichondrium. Peri means around, so it's around the cartilage. And that's going to act as a reserve of those mesenchyme cells and chondroblasts. So that way cartilage can continue to grow throughout life. Because remember, the only cells that are doing mitosis are those mesenchyme stem cells. The chondrocytes cannot do mitosis. There's not enough space in the lacuna for there to be 2 cells. The chondroblasts are not going to do mitosis. They're going to grow up and turn into chondrocytes. So the only cells that are doing mitosis are those mesenchyme stem cells that have differentiated into the cartilage stem, into the cartilage lineage. And those cells will continue to do mitosis and produce chondroblasts that will make the matrix. And they will continue to grow that cartilage throughout your life, which is why as we get older, sometimes our ears are bigger and our nose continues to get bigger as we get older because this perichondrium, which has those stem cells, is still there, and those cells are turning into chondroplasts that build bigger noses and ears. When it comes to cartilage, remember that it is avascular, so there's no blood capillaries, meaning that the cells are going to rely on diffusion to bring the nutrients in and to remove waste. This is why when you have damage to cartilage tissue, it heals very slowly because there's not blood vessels bringing in those nutrients that's needed for cell healing. The matrix is going to be really rich in those aminoglycoproteins, and they're also going to contain collagen fiber. So there are 3 different types of cartilage, and they will vary with the fibers that they are made out of. Right? So we'll talk about hyaline cartilage first, then fibrocartilage, then elastic cartilage. Hyaline cartilage is known for its glassy looking appearance. The ground substance is firm, and we're going to see those cells trapped in a lacuna. So I would like to bring your attention to the avocado looking structures in the lower right hand side. Right, so these structures or cavities are the lacuna. And then the little darker circle inside, which would be like the seed of the avocado, that is the actual chondrocyte that is maintaining the hyaline cartilage. So a lot of times when we look at this under the microscope, that ground substance is a pretty purple color, and it does look pretty transparent or clear. And that is because there are very few collagen fibers that are running through it, but there are some. So we find this in the larynx, in the bridge of our nose, in our ribs. So here is a picture, a histology picture of that hyaline cartilage. So you can see the avocado looking structures, that darker purple or bluish, that is the lacuna. And then the cell is that little pinkish purplish stain in the middle of the lacuna. And then where there's that empty looking space that's kind of clear or glass looking, that is that extracellular matrix. Here we have some more histological images, and the glassy appearance is because of the fineness of the collagen fibers. So they're pretty hard to actually see in these pictures, but if you look very, very, very closely, you can kind of see them and, nestled throughout the matrix. This cartilage is going to ease joint movement, help hold airways open, and help move the vocal cords. So we're going to find them in the trachea and in the larynx. And we're going to see a lot of hyaline cartilage actually in the fetal skeleton because it's going to create a framework and template for our bones to be built on. So we will talk a lot about it in the skeletal system. Fibrocartilage is going to look very similar to hyaline cartilage, except now we're going to see lots of those collagen fibers. So those fibers are mostly going to be running in parallel, but there is going to be some, swerves as they're going around the lacuna. The most common place that we're going to find this fibrocartilage is going to be in the intervertebral spaces, so the space between your vertebrae. This is what that fibrocartilage actually looks like underneath the microscope. So you can see those mostly parallel collagen fibers. And then you can see the lacuna, and the little purple dot is the actual cell. Those collagen fibers sometimes look like these coarse bundles, and they can look pretty large. And so where you see those little swirling fibers, those collagen fibers are going to help resist compression or squish and absorb shock, right? So that's a great place or a great tissue to have in between the discs of our spine, in like the meniscus of our knee, or in the pubis symphysis that joins our hip bones together in the anterior portion of the skeleton. Then we've got elastic cartilage. So this is highly flexible because it's got more elastic fibers. So if you think about the places on our body where there's a lot of flexibility, like the outer part of our ear or even like the very tip of your nose, that's because of these elastic fibers that are in the cartilage. So the ground substance is going to be the same. It's going to be a firm, rubbery type of ground substance, But now with the collagen fibers, I'm going to have some elastin fibers too that will allow the tissue to go back to its original shape. So here's what that actually looks like underneath a microscope. You can see the lacuna with the cells, and then you can see the elastin fibers are the swirly ones, or where you see them kind of crinkled, where they kind of bundle up. And then the collagen are the more wispy fibers. But you can see the elastin fibers running through. Here's some other images that are pretty good showing those elastin fibers. And these guys are also going to be covered with the perichondrium that has those stem cells that can differentiate into the chondroblast. When it comes to bone, bone is a connective tissue, except the ground substance is now calcified. So it's even more tough than the firm ground substance that we have in cartilage. So there are two types of bone tissue. There is spongy bone and there is compact bone. We also refer to bone as osseous tissue. Right? So if you were to look at the characteristics of bone tissue, this is going to come from the same mesenchyme stem cell line, but now we have the osteogenic cells that have committed to turning into bone. So you're going to have osteoblasts that build the bone. They secrete ground substance, they make the fibers, they secrete collagen and other fluids. And as they build up that ground substance, they're going to incorporate calcium and minerals into that ground substance, and it's going to calcify it and make it very, very hardened. So as these osteoblasts build the bone, they are going to trap themselves in a lacuna. They will build that ground substance all the way around them and calcify it until they are stuck in a very small space. So that space is called a lacuna, just like what we saw in cartilage. And once these cells are trapped in the lacuna, they are going to differentiate and they will turn into an osteocyte, where they will maintain the bone tissue. They will communicate with one another, communicate with other cells, and maintain that bone tissue. So if you look at this bone tissue on the left of the screen, that is actually compact bone. And you can see that there are these rings. And so what's in the middle, that darkish part in the very middle, that is actually a structure called the Haversian canal. And the Haversian canal has blood vessels and nerves running through it. And then you see these concentric rings that go around the central canal. And these little dark spaces in those concentric rings, those are the lacuna that are holding these osteocytes. With bone or osseous tissue, this is the only calcified connective tissue, and it composes the skeleton. So we'll get all into the nitty-gritty details, but this is going to provide us a really good foundation for our skeletal unit. When these osteoblasts are building the bone, they're going to build two different types. There is spongy bone that is a more delicate branching, like kind of these beam or bridges, kind of like slivers, and it gives off a spongy appearance, which is why it gets its name of spongy bone. We're going to find this on the heads or at the ends of our long bones, and then in the middle of our flat bones like our sternum. Compact bone or dense bone is going to be more dense. There's going to be more bone in the same amount of space. So in compact bone, there's not going to be these visible spaces like what we see in the spongy bone. And this is going to form the external surfaces of all of our different bones. Compact bone is going to be arranged in cylinders, and at the very center of the cylinder is the Haversian canal, which we are now calling the central canal, and I need to get better at that. It's called the central canal. Haversian is just named after the dude who discovered it, and we're trying to move away from those types of names. So central canal. This passage runs longitudinally along the length of the bone, and it contains blood vessels and nerves. And then there's going to be ring-like layers surrounding that central canal. Those are called lamellae. And then there's going to be these little delicate canals that connect the lamellae to one another and to that central canal. And it's also going to connect all of the osteocytes that are trapped within the lacuna. And that's going to allow the osteocytes to connect to one another and actually communicate. It's also going to provide a way for nutrients to move from that central canal and get to each one of those osteocytes that are trapped within the lacuna. And then we have the entire structure, that's the central canal and all of the surrounding lamellae, that is called the osteon. That is the functional unit of compact bone. And then the outermost layer of the bone is going to be a connective tissue that's called the periosteum. That is a tough, fibrous connective tissue that covers the whole bone. So if we look at the histology of compact bone, you can see those central canals right in the middle, right? And then you see these rings. I'm actually going to draw this. So I have my central canal that's going to have all my blood vessels and my neurons, my nerves. Okay. And then I'm going to have the concentric rings. So here's one lamellae. Here's another lamellae. And I'll just do 3 lamellae. 3 lamellae. This whole unit of those lamellae and that central canal is called the osteon. Okay, the whole thing is the osteon. So in these lamellae, we're going to see these little homes called lacuna, and that is where these osteocytes live because they are trapped. But they're living cells, so they need nutrients and they need to get rid of their waste. Well, the nutrients are going to be delivered from the blood vessels in that Haversian canal. So nutrients are going to have to diffuse from that central canal to the lacuna. So it's going to connect the central canal to the lamellae and lamellae to lamellae and osteocyte to osteocyte are canaliculi. So these little connections are the canaliculi, right? And so if you look at this guy right here, he kind of looks like a bug, right? That body is the lacuna that is holding the osteocyte. And then what looks like the little legs coming off of it, those are the canaliculi. And these canaliculi will go from lamellae to lamellae, connecting all of the lacuna together and to the central Haversian canal for nutrients and to get rid of waste products. So if we were to zoom in on one of those canaliculi, right, it would be like if I took a cross section, it'd be like a long tube or canal. And let's say at the end of this canaliculi, there is a lacuna. And it goes to the lamellae that has another lacuna. And inside of this lacuna is a cell that has an arm that's kind of reaching through that canaliculi, that canal. And then in the other lacuna is another cell that has another arm that's reaching out towards that other cell. And so they're trying to make contact here. And then they're going to be able to communicate and talk to one another so they can maintain this bone tissue together. Blood is also a connective tissue, and it is the only liquid or fluid connective tissue, and it's going to travel through our blood vessels. So this might be kind of counterintuitive because it's a fluid, but it does meet all of the requirements to be classified as a connective tissue, right? So it has cells, and those cells are used to transport materials like oxygen. And then there is a liquid component. So those cells are known as formed elements, and they are going to include your erythrocytes, which are your red blood cells for the transportation of oxygen. And then there is the leukocytes, which are your white blood cells or your immune cells. And then you also have platelets. And platelets are actually just fragments of other cells that are involved for clotting. So these formed elements are like the fibers. And then the ground substance would be like the liquid component called the blood plasma. So some of the fibers or formed elements that we find in blood include our leukocytes. So one type of white blood cell that we're going to find is called a mast cell. These guys are really good at detecting foreign substances, and they contain these little granules that secrete inflammatory chemicals. Macrophages are another type of leukocyte or white blood cell that are more blob-like that engulf invading substances or organisms. So they are going to be involved in your immunity like the mast cells, but those two cell types are going to have different types of involvements. The mast cells will alert your immune system, while the macrophages are actually going to be the ones who break down the foreign debris themselves. And then you have your erythrocytes, which are the red blood cells that carry oxygen. Right, so we're also going to have a lot of other types of leukocytes or white blood cells that can provide an immune response. So when you're looking at these cells, the red blood cells or erythrocytes are much smaller. They're also biconcave, so they have this little indentation, where the white blood cells are going to be larger and they are more circular in shape. So if we look at this underneath a microscope, all of the little white circles, or red circles, I'm sorry, those are the erythrocytes. And then where you see the little chunkies, like the little things like this guy or like this here, those are the platelets, right? So those are fragments of other cells. And then these larger guys, these are the leukocytes. They're the white blood cells that are part of your immune system. And we identify them by the shape of the nucleus. So neutrophils have this multi-lobed, typically 3 lobes for the nucleus, while the lymphocytes will have one large nucleus that takes up a majority of the cell size. And then the monocyte is just this massive cell that kind of looks like there are two lobes to the nucleus. And some additional leukocytes that you might see are eosinophils, which have these little granules in them. You also might see what's called an eosinophil, which has two lobed to the nucleus. We'll talk a lot more about these when you go into the cardiovascular system in 202. So for now, just be aware that they are different types of leukocytes. And we'll talk more about tissues coming up. So we just hit 30 minutes.